All right. So here we are with Node, and so simply I'm going to focus is on the quick over. I'm going to recap the GraphQL section. Okay, a quick recap of that because I know what GraphQL is. It's a new query language. That the beauty of this is that it allows us to see how different pieces of data relate in our server, and it all starts by describing is the data using schemas. And if you want to ask for data, you rely on queries, GraphQL queries. So this is much like selecting property from an object, and the whole idea is that and the benefit of using GraphQL is one of them because our query really match closely what is the resulting object. We can predict what our query will return, including is the property of that object, regardless how the data is stored. Whether you use a relational, document-based, key-value, graph, or white column database. And because this is something that was created by Facebook in 2012, uh, there is some issue that this type of building APIs and how do we interact with them solve. Like, for example, in GraphQL, because we have this collection of objects, anytime that we want to query a collection, we have to make an individual request and individual response. And if you want to combine data, so you find out quickly through the server with incoming requests. So there's two main issues that GraphQL solves: the underfetching and the overfetching. So underfetching is we lose time making additional unnecessary requests to our servers to query multiple collections, increasing the page load time. And the other is overfetching because our server serves additionally data that we don't need, and it wants to show relevant data to the user, we need to filter out. So the way how GraphQL solves these two issues by having one single entry point or a GraphQL entry point. So there is no more underfetching because all of those entry points, all of the requests are going to be done in a single entry point. The GraphQL server send the relevant data and only the data that we want. So also solving the overfetching issue. And the another benefit of using GraphQL is that it provides schemas and types. So we have already a document code base, and it speeds up the development. Of course, for developers that are familiar with this, and that's one of the trade-offs, because since this is not a RESTful architecture where most developers are familiar with that, the learning curve can be quite steep. And another trade-off is that since with RESTful we have already proven caching methods, here caching is something quite complex. It's an advanced topic, and GraphQL has a particular section for that. So it's not that it's not a out of the box tool that you can include that, right? And this flexibility that GraphQL provides you comes with a complexity or this learning curve. In any case, I started to look at how can we create our first query using tools like GraphQL, where allow you to make queries to a GraphQL service, and by default GraphQL servers fetch data, where you can also inside of that define is a property that you want to get from, and it is very trivial to compose really complex data structure and get only the data that you want. This is another benefit of using GraphQL. Querying composition, or uh, getting deep nested objects from from your application. An example, a very common example of that are e-commerce or any application with some technical depth. So to understand this, I look at the GraphQL specification if from their website, the GraphQL specification here, and the front-end tools using the React framework such as Relay, and a more high-end product to build front-end and back-ends such as Apollo. So before I dive deep into those high-end products, I started to see how, or I saw how can I build this GraphQL from scratch by looking at the specifications and import the GraphQL package and include the GraphQL Express middleware. So I started to saw how can I create is a type system, and this type system, okay, like this, and this type system describe the GraphQL capability, or this the GraphQL type system describe the capability of a GraphQL service that is used to determine if a request operation is valid, the type of the response, and describe the input type of variables to determine if the value provided at request times are valid. So this is the three things that is being used in this type system. So I started to define a pretty simple example by using is the build schema from the GraphQL, also so defining the type system like this. Here, and defining the type systems. All GraphQL servers start with type query, which is the entry point. And as I move on, by looking at how can we test GraphQL endpoint, how can we send data to that, specifically test a GraphQL endpoint using Postman's or Insomnia. Sorry. And how this rely in HTTP post verb. So that's one of the reasons why it's not a RESTful. And then defining is a more realistic project by creating is a e-commerce. So very deep nested objects are very common in e-commerce applications or any application with some technical depth, making GraphQL a perfect candidate for that. And it is actually very easy to how can we query really complex data structures for the data that we need. So our API is organized in types and fields rather than endpoints. So making multiple endpoints or querying multiple endpoints, like in a RESTful architecture, unnecessary. So, because if we want to make our life much more easy when creating a GraphQL service, so our projects must or can rely on tools like GraphQL tools, all right, that allow you is to break your multiple types in or break your types in multiple files, break your server capability by organize your code by features, and help you organize help you organize mm, okay, I didn't have this open. And here we are with the readme. Exactly. And organize our server when we need to add more complex logic to fetch our data. So these are the three main questions, okay, is that come out when as our applications grow. Okay, it's like how can we break down our type into multiple files, structure projects based on functionality, and organize our server when we need to add complex or more complex logic to fetch our data. Okay, so GraphQL tools is greatly help us here because it's an open source of set of utility of how we make GraphQL server, and it is used under the hood by Apollo GraphQL framework. So it's not a good idea. Depend how is your how do you align how your business align with GraphQL. Okay, but it's not always a good idea to fully commit to a particular service due to the flexibility reasons. Again, it's up to you and the company. But so the way how do we answer those questions? Okay, meaning modularizing large GraphQL projects with schemas. Okay, so here I look at so in there by relying on tools like GraphQL tools, functions such as makes executable that allows you to import inside an array of type as a string, and tools like load files where by passing in a glob or a regular expressions to look out for your for GraphQL files in your project structure, we can easily import multiple types in our uh, schema, in this case in our makes executable function, okay, in our schema, and help us organize our first help us organize our project based on functionality, break our type into multiple files, which is great. And this approach is great for or when you don't. So this approach is great when you define proper types and there is no name conflict. So I look at how can we do that. All right. but also is using is the .graphql files for defining your types. And another important thing is that in any GraphQL servers, it has two main components according to the zero to mastering structure. So you have schemas and the resolvers. So what are resolvers? So the answer lies is on how do we query our GraphQL servers. So GraphQL servers, or GraphQL, always makes sure that a query is valid by looking at our schemas and then execute that query. So executing that query, okay? So when executing that query, the value of the property is determined by a function called resolvers. So at the end of the day, looking at these two components, the schema and the resolvers in the GraphQL server, and asking the question, so what are resolvers? So the answer, and I know I'm repeating myself here, is just to solidify the narrative that I'm building here. So because resolvers, so what are resolvers? The answer lies in how we query. So GraphQL always check if a query, so GraphQL always check if a GraphQL query is valid by looking at the type system and then execute that query. So when executing the query, the value of the property are determined by a function called resolvers. So when you define a query, each property is called their proper resolver. So when you have multiple properties, the server will call all of those resolvers and wrap up and send back to the front. So that's the whole narrative or the whole story of what are resolvers according to zero to mastering structures. So what are resolvers and what are their functions in terms of functionality? So what are resolvers in terms of functionality? So all right, cool. I also look at how can we create our first resolvers using is the max executable function, where you can is defined here as the resolver property. Okay, and in there we can is match by defining is a query and the products and orders in our case. Remember that must match your type system, right? So anytime a query or when a query, so GraphQL check if a query is valid by looking at their schema and they execute the proper query. So the way it works, this resolver is GraphQL calls one of the required resolvers. So we fetch the data that we need inside of our resolver or the function, and that data gets sent back to the client. So again, this is if someone asks me, hey Oliver, what are resolvers? First, you need to understand that that's one of the two main components in any GraphQL server. So we have schema and resolvers. So schema allow us to define is the capability of a GraphQL service, that schemas, all right? We also by using these tools like GraphQL tools package, make your GraphQL server much more modularized, which makes much more modular your app. meaning, so you break your type into multiple files and organize your project based on functionality. For example, projects and orders, since we are here for demo purpose, we are building or I am building a e-commerce application. Okay, so we define schemas, but what are resolvers? Well, so resolve. Sorry. So resolvers are yes. So resolvers are, how do you say it? Right again. So yeah, a resolver is a function that allows you to determine the value of a property. Okay, but all of this happen when a GraphQL is valid. So at the beginning, when you are making a query to a GraphQL service, GraphQL check if that query is valid by checking at the type system and then execute the query. So while executing the query, the value of the property is determined by a function called resolve. TLDR, a resolver is a function that allows to determine the value of a property in a GraphQL query, right? In a query. Okay. So this function have couple arguments. So the first is the parent, which is start with the root value. The other is the arg, is being used when we have parameterized queries. This is a word that took me a while to pronounce. Okay. I think you're not working. What about now? Okay. So I have parent that start with the root value. Args being used when you have parameterized queries. Parameterized, exactly. R is being used when we have parameterized queries. Context, an example of argument, for example, filter out data under some conditions. Context is for data that can be shared across different resolvers. For example, if you want to pass authentication data about which user logging into everyone for all resolvers. Again, context is for data. So context is for data that can be shared across different resolvers. For example, if you want to pass authentication data about which user login, okay, if you want to pass authentication data about which user login to everyone. Okay, if we want to pass authentication data about which user login for all of our resolvers. It's quite redundant. For all for all of our resolvers. For all resolvers. And info is data that contains the information about the state of the operation. So info contains information about the state of the operation. Context is being used for shared data across different resolvers. For example, if you want to pass authentication data about which user login for all of our resolvers, args is being used when we have parameterized queries. Okay. Parameterized queries. Type def and type arrive, resolve query. Okay. So once I look at the anatomy of the resolvers, so the beauty of this is that now here we can make async database operation. That's the beauty of the resolver, is that allows us to make asynchronous API database operation, or meaning or API calls. So once I look what is a resolver, how can we do, how can we create our resolvers? Okay. Uh, I also look. I look at modelizing large GraphQL project with resolvers, and again, much like the much like the same what we did. Yeah, much like the same what we did with our schemas is pretty much the same for our resolvers. But here we're going to define is a file that ends with dot resolvers. We're going to export that model, okay, and we're going to define is an object with the query option here, much like the same here as a resolver, with a query option here, okay, and defining is the query for that, right? Define is the query for that. So since we are mocking, since we're fetching data, since we are sending data to the client, since we are sending mock data to our client, okay, that is not realistic because we're getting all of this data in memory. Uh, so we build our, or we scale our resolvers uh, by importing is the from the data layer. This is something that is I'm going to follow this instruction here because otherwise I'm just is taking too much time to mention that. So we're talking about here on the resolvers. So how do we organize our project just like we did with our schema, but in this with our resolvers? Since organized resolver function with hard-coded data is not very realistic, exactly. Organized Organized resolver function with hard-coded data is not very realistic. In large-scale project, you have the data layer. Exactly. In large-scale project, you have the data layer. This is the data layer, the product model. In large-scale project, you have the data layer. For example, product model. Exactly, product model. And this function will make whatever API call we need. In our case, in large scale apps here, you have the data layer. Okay. In large scale project, you have the data layer. So in large scale project, you have the data layer. Exactly. So in large scale project, you have Yeah, in large scale project, you have the data layer, for example, the product model, and this function in this data layer, and this function get all product, get product by price, get product by ID, and this function will make whatever API call we need. Exactly, in the data layer. So our model will export all of these data access functions. So our model will export all of this data access layer. And this is something important to understand. Before moving on, data layers in Node.js architecture. Data layer. Very English. This is how to display data layer, heat maps, review. But this is from Google Maps. That access layer in Node.js expression, but I'm more interested uh, in data or architecture node. DAC or Node.js architecture updated. Simply learn, medium, gigs, 4 gigs, data ocean. But I think it's mm, is this gonna explain me is the exactly no, but what I mean is by that is the uh, okay okay. Project structure, um, blog rocket, and again looking for source, second party data source, um, separate business logic and API routes. Use a service layer. Yeah, but these recommendations are opinionated. Exactly. Separate our business logic from our API routes. Controller, the route, the service, and the data layer access. hmm Again, this is from Log Rocket. What if I go back here? From you. What about Joan? What about Joan here? By looking at the design. Developers getting started, documentation. No, but this is for the documentation here. Uh, uh, Error handling with freedom here, but design exactly from the design. The meter, string, control flow, coding style, logging, client server, specific software, error handling. But it doesn't tell you anything related to. Yeah, it doesn't tell you anything related to that. To architecture because this is okay. Node.js project architecture. We have this from this first source. Okay, concatenated testing, but are found early, cost reduction. Is another layer for third-party service call, pops up pattern, use a linter, use a style guide, come in your go, keep an eye on your file size, use GC dump, use promise, monitor fail and slow network request in production. Mm, 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 mm. Developer Red Hat. Reference architecture. Okay. So coverage, TypeScript, logging, code consistency, GraphQL in Node, my friend. Mm-hmm. Mm-hmm. Read, obey, and delete. Uh, mm, mm, interface application and domain, infrastructure, domain-driven design. Software design is a very software design is very hard thing. For years, a trend has appeared to put the business logic, aka the business domain, and with the user in the heart of overall system. Based on this concept, different architecture pattern was imagined. On the first main was introduced by Evan, domain-driven design approach. Okay, okay. Mm, application source, application service layer, security, use case, domain, infrastructure, config, service locator, ORM, mongoose, repositories, implementation of domain repository interface, security, tools implementations, GWT access token manager, web server, Happy.js, web server configuration, server routes plugin, OAuth, Happy.js service definition, interface, controller route and serializers. But this is the project anatomy of a Happy. What you have is the infrastructure. Using is a clean architecture. A simple API built with Happy that follows TDD plus clean architecture principle. Okay, but again, this is one type of architecture. And again, those architecture may adapt based on the client problems need. Mhm. Separating our business logic from API routes. Use a service layer for managing requests view and route. Use such support into our API route, but this will quickly make it into a giant monolithic block that will review to be manageable, hard to read and prone to decompose. hmm Why project architecture is important? Best practice for Node.js project structure. Create a folder structure for all of your projects. Exactly. Create a project folder for you. Use a service layer. But if we look at this, we have the entity use case controller and web devices. But the question is that where do you know the Node.js architect project architecture? Project architecture design. Hmm. Yeah, because most of them are following is the clean architecture. And of course is the architecture of a project. Okay. Node.js architecture project. Mhm. Unless we're starting to get used ChatGPT for this. Oh god. Mm-hmm. ChatGPT is at capacity right now. Wow. Oh god. Holy crap. For real? Okay. 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 Amiga. Yeah, but you're following is this architecture, right? You're following is a clean architecture, the domain-driven design approach. The domain-driven design approach, an hexagonal architecture. Yeah, but most of the time, all of us follow this. This architecture. Mhm. GitHub provide a project structure. No. Yeah, but one of them is best practice and the others are architecture. What is best practice? 80,000 stars, motion should rise, and proud. It's a large compilation and is growing every week. Best practice has additional info. Project structure practice. Structure your solution by components. Strategic. Layer your components. Layer your component. Keep the web layer within its boundaries. Wrap common utility as npm package. Separate express app and server. Use environment aware, secure and hierarchical config. Error handling practice. Use a sync await promise for async error handling. Use only built-in error object. Distinguish operational versus programmer error. Exactly. Distinguish operational versus programmer error. Handle error centrally. This is something comes from Joe, a long-term Node.js sponsor. Handle errors centrally, not within a middleware. Exactly. Document API errors using Swagger or GraphQL. Modified recently. Exit the process gracefully when a stranger comes to town. Use Material Logger to increase error visibility. Test error flow using your favorite test framework. Discover errors and downtime using APM products. Catch and handle promise rejection. Modify recently. Fail fast. Validate arguments using a dedicated library. Always await promise before returning to avoid a partial state track. Always await promise before returning to avoid a partial stack trace. Go to production practice. Interesting. Use tools that automatically detect vulnerabilities. Security practice. Performance practice. Don't block the event loop. Prefer native JS method over userland utils like Lodash. Docker practice. Bootstrap using no commands avoid npm star. Let the Docker runtime handle replication and uptime. Mhm. Interesting. Very, very, very interesting. That is a production ready package with best practice and building with simplicity in mind. Generate a Node.js app that is packed with the best practice and simplicity in mind, based off or repo Node.js practice. Super quick setup or philosophy and unique values, practice and feature the people behind Practical.js, or best practice guide 78,000 star contributor documentation. Example application: Express PostgreSQL with common best practice with MongoDB. Specs Postgres with all best practice advanced. Minimal with project setup. Interesting. Harder and Docker.5. Real world testing with DB. Mhm. Exactly. Which this generate request, API logic, and DB. Generating microservice code. Simplicity. And this is the hierarchy that they follow. Exactly. Secondary driven adapter and primary driven adapter. Three-tier architecture. Mhm. This is the graph that I want to look. Primary driven adapters. Secondary driven adapters. This is a video from understanding all of this, but use only what you need. This is the domain layer service. Mhm. And here's what you have: the domain layer, application layer, or the data layer. But here there is nothing, but there is nothing like that. Application core, command query bus, and event bus. ORM, an adapter, search adapter, email adapter, SMS adapter, event bus adapter, CQ bus adapter, primary driven adapter, admin key, VM controllers. These are the primary driven adapters. Sub REST controllers. But it's funny because or REST or GraphQL. Dependency going inward. Application layer, domain layer, and application core. Where did this image come from? Okay, and also contributor. Okay. Interesting. Yeah, I'm going to wrap this up. Uh, yeah, I'm going to wrap this up um, for today. And yeah, I'm going to wrap this for today. And see you in the next episode. Take care. Bye bye.